Hi, and welcome to our last video lesson in Benchmark 2 on digestion. So far, you've investigated why we eat, and you've learned a little bit about acids and bases and the pH scale. Now let's put it all together by talking about the different organs of the digestive system. A lot of these you're already familiar with. Basically, the purpose of digestion is to take the food we eat and break it down into pieces that are small enough that our body can absorb into the bloodstream. In many cases, we're getting things down to the molecular level. So it's a good lesson in chemistry as well. So in the next few slides, you're going to get a quick overview of the organs of the digestive system. It's not a complete list, but most of the important organs are discussed. Once you've watched this video lesson, your graded activity will be to do another coloring sheet and a worksheet going over each function of each organ. There are different varieties in the ECHO activity, and there's some online matching games that you can play as well. So on each slide, as we go through each organ in order from start to finish, you'll notice that I've discussed how things are broken down both mechanically and chemically. So pay very careful attention to each of those things. So when I say mechanically broken down, I mean there's moving parts involved. Chemically means there's some sort of chemical compound that's aiding and breaking things down. And we've already talked about acids, and there's a lot of acid throughout your digestive tract to help with chemical digestion. So if you've had lunch today or breakfast or any meal, you know that everything starts at the mouth. And your mouth is specially designed to break down food. And you might be thinking, well, yeah, I know I chew my food, or at least I hope you chew your food. That must just be a mechanical digestion. There's actually a lot of stuff going on in your mouth of the chemical nature. So your teeth and your tongue break down food mechanically, but the saliva in your mouth actually contains enzymes that speed up the process of breaking down your food. Now here's a really cool experiment you can do. You can actually put one saltine cracker in your mouth, and without chewing it, you can let your saliva break down the really complex starch carbohydrates in the cracker into simpler carbohydrates. So if you have the stomach for it, and you have the patience, you can actually allow a saltine cracker to dissolve in your saliva, and it'll actually turn sweet because as starch is broken down, it turns into glucose, which is a simple sugar. So once you've swallowed your food, it goes to the esophagus, and as you swallow, we have a special mechanism to make sure that it does not go down our windpipe, okay, or our trachea. Okay, that would be choking, and we don't want that. And your esophagus is actually a really long muscular tube that connects the mouth to the stomach. So your epiglottis seals off the trachea when you swallow food, literally so you don't inhale food. If people have, let's say they have an instance where they vomit and they're unconscious, there's a real risk to aspirating things and not knowing it. Very, very dangerous to get food particles anywhere past your trachea or into your lungs. It's mucus lined. So your esophagus is lined with mucus to help make food literally slide down. And smooth muscle will actually keep it moving. So here's something interesting. I don't want you to try this at home because I don't want you to choke. But you can actually swallow and get food down into your stomach upside down or at any angle. Really, your body gets it to your stomach one way or another. So there's this wave-like motion of the muscles in your esophagus that's called peristalsis. And if you've ever experienced throwing up, you have experienced reverse peristalsis, which is basically the muscles changing direction and getting rid of whatever is in your stomach up and through your esophagus. And if you've had that experience, and most of us have, you know that there's an awful, awful burning sensation. And despite having mucus in our esophagus, it can actually be very painful to have stomach acid pass through the esophagus. So there are limitations to keeping the acid from causing us pain. All right, so your stomach is like such a cool organ. There are a lot of different things to talk about where the stomach is involved. And you can see that this picture right here is pretty complex. So we're not going to get into too much detail, but you basically have muscle all throughout your stomach to churn food mechanically. So although your teeth do a lot, your stomach actually churns food and squishes it around to break down things mechanically as well. There's a lot of stuff going on. There's a bunch of tiny little folds full of mucus that are increasing the surface area in your stomach. They're providing a very safe layer of mucus so that the stomach acid being produced doesn't eat away at your stomach tissue. And it's constantly secreting both enzymes and digestive acids to chemically digest food. So I haven't really explained what enzymes are. Enzymes are a special chemical that your body makes that speed up other chemical reactions. So they're just like helper molecules to get things done faster. And if you don't have certain enzymes, it can make digestion really hard. So there's muscle squeezing your stomach. Your stomach's actually not really that big, but it can stretch to accommodate. If you've ever watched eating contests on like food channels, it's insane how much food people can eat. And there are people who have surgery to reduce the size of their stomach for weight loss purposes, and they actually will pinch off part of the stomach just to make the stomach cavity smaller. So your stomach is kind of off to the side. It's kind of kidney shaped in a way. Whenever you see the word pyloric or pylorus, it's usually something to do with the stomach. And there are valves that close off the stomach, both at the top to the esophagus and at the bottom where it connects to your small intestine. So you can actually see this one really clearly. This is called the pyloric sphincter, and it will only allow certain amounts of material to leave the stomach at a time. So your food is going to leave the stomach in liquid form. So remember, you started the food in your mouth, you chewed it up, it kind of got squishy and liquidy. Your stomach's going to do a lot more digestion, both mechanically and chemically. And then the next pit stop is the small intestine. And from this point on, the food is going to remain in kind of a slushy, liquidy acid form. All right, so your small intestine takes up a lot of space in your internal body cavity. It's really long. The process of absorbing food takes a long time, and it's happening throughout all 6 meters, that's about 18 feet, of your small intestine. And it's pretty small diameter, that's why it's called your small intestine, but inside of it are all these little finger-like projections. So these are really tiny. They're not easy to see with the naked eye, and they are full of blood vessels. Okay, nerves, there's capillary networks, there's lymph for your immune system, and this is where the chemical absorption of your food takes place. Okay, so there is more chemical digestion occurring. There are molecules that are getting further digested by acids in your small intestine. There are other chemicals involved secreted by both the liver and the pancreas. So they would be considered accessory organs to the digestive system. And basically, everything that you've eaten and is now in liquid form has to be now small enough to pass through these villi, these finger-like projections, and to be absorbed into the fluids of the body. So this is a really, really important step in our digestion. The food we eat needs to get into our bloodstream. Now, the liver, pancreas, and gallbladder are considered somewhat accessory organs to digestion, but they do produce a lot of things that our body needs to keep digestion going smoothly. Your liver, which actually takes up over half of your torso internal body cavity, is made up of 3 large lobes, and it produces bile, which is a chemical needed to break up fat particles. Your gallbladder is basically a little sac next to your liver that will store the bile until it's pumped into the small intestine. So you need this chemical to properly break down fat. So here's a little side note. If you know somebody who's had their gallbladder removed, you can certainly live without your gallbladder, but you don't have that backup supply of bile to help you break down fat. So people who've had their gallbladder removed often reported prior to having it removed difficulty eating fatty foods, or they may have had a gallbladder attack. The bile duct can actually get clogged. And after the gallbladder's been removed, generally speaking, people need to stay away from fatty foods just because it's really tough on the digestive system. The small intestine actually, this looks like a macaroni noodle, but it's actually just a cross section of the intestine that kind of snuggles right up in here and is receiving bile from the bile duct in the gallbladder. It's also right here next to the pancreas. The pancreas produces a lot of enzymes that are pumped directly into the small intestine, and a lot of these break down starch, proteins, and fat. And the pancreas plays a big role in our immunity as well as our control of blood sugar levels. All right, so we're almost done with digestion. And depending on the person, the process of digestion can take quite a wide variety of time. If you're sick and you have some sort of a bug that causes you to have diarrhea, things can go through your system really, really quickly. And it really depends on your metabolism and how active you are. So we've gone from the mouth to the esophagus to the stomach. We've stopped at the small intestine and talked a little bit about the accessory organs. Now we're going to talk about the large intestine. Now your large intestine is sometimes called your colon, and it has three main sections. So here's where the small intestine enters. It's called the ileum. And the small intestine connects at what we call the ascending colon. It's called ascending because it goes up. All right. Now, your body has basically had this slushy sludge of acidic liquid flowing through it for a while, and the small intestine has done a really good job absorbing nutrients into your bloodstream. Now, there's a lot of liquid left, and your colon does a really great job collecting excessive water. And this will put the water back into the bloodstream and prevent us from being dehydrated. Now, if you have diarrhea, your body doesn't have time to reabsorb this water. And if you've had a sickness associated with diarrhea, you know that the real danger in those illnesses is actually becoming dehydrated. So there's a whole network of blood vessels connected directly to the colon. So as the waste product passes through the colon, and I shouldn't say waste because there is still some absorption of minerals and vitamins through your large intestine, but for the most part, your body's just working on getting its water back. There are a lot of bacteria that live in your large intestine. It's a symbiotic relationship. They help you to further break down the food that you're no longer needing, and then they get some food themselves. The bacteria feed on the waste, but they also help in excretion of this waste product. So the ascending colon goes up, the transverse colon goes across your midsection, and the descending colon goes down. Now it takes a little turn. This is sometimes called the sigmoid colon. And at this point, your body's pretty close to being able to excrete the waste product. The waste product being feces, and it is excreted out through the rectum. All right, so that's digestion from start to finish. It is an essential part to human survival. All right, so we talked about chemical and physical changes throughout the entire digestive tract. There are acids at work throughout the entire process, and your body's pH is highly regulated throughout your entire digestive tract. Molecules are constantly being changed into different molecules. So we're talking about chemical changes. The elements stay the same because, hey, we learned that in chemistry. It's a conservation of matter. Now, here's your activity for today. You need to go into Echo and decide if you want to do the coloring sheet, which needs to be printed, or if you want to do the online game where you have to identify organs and take a screenshot. The activity on the back or second page is a worksheet where you have to describe the function of all the 7 organs talked about today in the digestive tract. You'll need to submit that in Echo, and that is the end of Benchmark 2. If you have any questions, make sure you come to the Zoom meeting. They are on Thursdays at 10:30. Thanks.